We're going to introduce now the concept of heat capacity, and it's probably a very important concept because it's a concept that relates heat and temperature or increment of temperature. In other words, when you can think of, like, you're in the kitchen and you are putting a pot on the stove, there you are providing heat to, hopefully, maybe you may want to boil some water. What is the relationship between heat and water? Sorry, between heat and the change of temperature. You may have experienced that it takes longer to boil oil than to boil water. Okay, so it's not a straightforward relationship between how much heat you need to provide to create a change of temperature in a system. Some systems, some substances require more heat for the same increment of temperature. This relationship is what heat capacity does. Something that one must also realize is that it's not only the kind of substance, but also how much substances. How much substance. So, for example, it takes more heat to boil 1 gallon of water than to boil 1 ounce of water, right? So even if it's the same substance, the more mass you have of that substance, the more heat you will need to provide to create a change of temperature, to create the same change of temperature. So that's what the heat capacity is. The heat capacity, by definition, is it's the ratio between heat and change of temperature. In other words, how much heat it takes for, in this case, 1 degree of temperature, how much heat a substance can absorb to change 1 degree of temperature. And it's important that at the atomic level, think of it as the technical term would be the degrees of freedom that the molecule has, or if you will, the pockets. Some complex molecules will have a complex structure, therefore they can absorb more energy in that complex structure. Some simple molecules have a lower heat capacity because they cannot absorb that much energy. So think about like atomic pockets where they can put their energy. Okay, there is a formula. In this case, the formula that includes mass, it's called specific heat capacity. Okay, in this case, heat is related to the change of temperature with the heat capacity and the mass. In this case, specific heat capacity. I hope that makes some sense. There is some specific kinds of heat capacities. There is the CV when this heat capacity is measured at constant volume. There's the CP when this heat capacity is measured at constant pressure. We will not go through this. Most of the time we will talk about at constant pressure for obvious reasons. At 1 atmosphere, the pressure is always constant in our lab. But just so you know, there are two different kinds. When the mass is expressed in terms of moles, we will call this molar heat capacity. So specific heat capacity when the mass is in grams, molar heat capacity when the mass is in moles. Let's do a little bit of problem solving, or at least try to understand this expression. Okay? In this case, I'm just writing a sentence, and you are supposed to say if it's true or false. And I'm going to write in here this famous formula. The relationship between heat and change of temperature depends on the specific heat capacity and its mass in grams. So the same amount of heat is given to two metals of identical mass. So let's imagine metal 1 and metal 2, they have the same mass. Okay, we put them on the stove, and with some imagination you can imagine that we're providing some fire. I will ask you to be understanding of my limited drawing capacities. Alright, so we provide the same amount of heat. So heat here and heat here is the same. Okay, the one with the largest increase of temperature, it says, will have the largest heat capacity. True or false? Well, let's look at this. Based on this, the heat that we provide depends on this. Okay, let's say for the heat 1 and heat 2, and we said that heat 1 and heat 2 is the same. Heat 2, the mass is the same as well. The heat capacity for metal 2 They do not necessarily have to be the same. And the change in temperature for metal 2 and the change in temperature for metal, for changing temperature for metal 1 and metal 2. Alright, it says that we provide the same amount of heat, and it says that the largest increase of temperature will have the largest heat capacity. Alright, does that make some sense? I made a mistake here. This should be C1 increment of T2. Alright, if these two numbers are the same, but the heat capacities are different because they belong to different metals, right? The heat capacity is specific to a metal, to iron, to lead, to whatever. For these two numbers to be the same, if heat capacity here is larger, the increment of temperature will be lower. And if heat capacity here is lower, the change in temperature will be higher. So this is false. The increase of temperature will have, the largest increase of temperature will have the lowest or the smallest heat capacity. So imagine that this metal 2 provides ends up with the largest change of temperature. It will have to have the smallest heat capacity. Okay, so take home message: the higher the heat capacity is, the more heat you need to provide to create the same increase of temperature. Or, if you will, the higher the heat capacity, for the same amount of heat, the lower the change in temperature will be.